Welcome friends to LTechpedia. So now we will discuss about GATE 2016 question paper for electrical department, the concept of digital electronics. Now we will move to the problem. So first problem, a temperature in the range of 40 degree to 55 degree Celsius is to be measured with a resolution of 0.1 degree Celsius. The minimum number of ADC bits required to get a matching dynamic range of temperature sensor is. So it want to number of bits. So how many ADC? So they will provide analog signal. So it will be how many bits required to measure the minus 40 to 55 degree Celsius with the resolution 0.1 degree Celsius. So we go to the temperature range. So temperature range is minus 40 to 55 degree. Then we want to the total range. So we know the total range, then only move to the number of resolution calculation, then move to the number of bits. So total resolution is higher to lower. So 55 minus of minus 40 degree, so total is plus 95 degree Celsius. Resolution is 0.1 degree. So we want number of states. So how many steps we required? So this is digital. So how many steps we required mean range by resolution. So 95 degree Celsius divided by 0.1 degree. So totally 950 steps are required. From this ADC, normally we calculated the number of steps, number of bits means that is 2 power n, that will be less than or equal to that corresponding required value. Here 950 will be calculated for 2 power n. So 2 power n is 950 is less than or equal to 2 power n. So overall number of bit required to 100. Why? Because 2 power 10 is equal to 102 power 1024, that is 1024. So it will be less than of 950 less than or equal to 1024. So it value will calculated. So final number of bit will be 10. So for the sensor, temperature sensor, it required 10 bits for this problem. So final answer is 10. We move to the second problem. Consider 2:1 mux, then the Boolean expression for output F in terms of A and B. So here consider this is mux. So for this consideration, what is the output of F value? So we in consideration, so first to calculate B is equal to 0, second B is equal to 1. So in case, for the case here consider B is equal to 0 means the function F is equal to A naught. So here it will be A function here created as, so here NOT gate is available, output of NOT gate we get A bar value. Then here directly provided means it is A value. So we take. So in this consideration for F output function B is equal to 0. B is equal to 0 means B bar at the time output is A bar. So B bar A bar. Then second case B is equal to 1 plus B is equal to 1 means B, that the function output is equal to A. So it is rewritten as here A bar B bar plus A B B. It will be simplified in a terms of XOR gate. A XOR B the whole bar. X NOR, it is denoted as X NOR. The symbol of X NOR is dot of circle. XOR means plus of circle. So XOR consider as, actually XOR function is A B whole bar plus A bar B. This is the XOR gate. X NOR means whole term bar, A bar B bar A B. So the final answer for this function X NOR or else X bar XOR the whole bar. So this is the final answer for given problem. Next problem. The current state QA QB of two JK flip-flop system is 0. The current state of QA QB, so this function QA and QB of the two flip-flop function is 0 0. Assume that the clock rise time is much smaller than the delay time. So this clock rise time is much more smaller than the delay time of JK flip-flop. The next state of the system, so this condition, what is the next state of given problem? So in this problem they were provided synchronous counter. Why? Because this is synchronous counter. All the flip-flops are clocked in same time. This is synchronous counter. Asynchronous counter means the clock will be depends upon another counter. Once the master will be operated, the output will be provided to gate of another one triggering. So this is asynchronous, but here provided the synchronous counter. So for this consideration we want to calculate what is the next state of given system. So when clock is applied to the flip-flop, it will be change their state simultaneously, depends upon JK flip-flop output. So here clock will be applied means both are simultaneously operated. So first QA and QB, this is present state, then we want to the present input and next to the present next output value. So for this case JA and KA is 1 then at the condition we want to move JQA and QB is equal to 0. So this condition is initially 0 condition. So we consider clock pulse, so we neglect this one. So we move to the function of Q is equal to 0 0. So 0 0 means both the conditions are 0. At the time we will clocked here. So this is 0, this is also 0. Clocked here. So consider in this function JK equal to 1 1. Similarly bar KA bar JA bar also 1 1. The final answer of next state is 1 1. So we want to know about the excitation table for this given problem. So what is the next state of given problem is 1 1. This is the final answer for given problem. Then move to the next problem. 2-bit flash ADC is given below. The input is 0 less than or equal to Vin less than or equal to 2 volt. The expression for LSB, least significant of output B0, as a Boolean function of x2, x1 and x0. So we want to function LSB function B0. LSB, MSB is most significant bit. LSB means least significant bit. So here it is least significant bit. It considers the function of x0, x1, x2. So we want to function in terms of x1, x2, x3 value. Then move to the problem. So in this case we consider input and output. So we want only function of B0 value. So input is a totally 4 function, that is 2 power 2. So here input consider as 4 function. So 100, 200, 200, 100 final. Totally this 4 function is combined input. So here provided output function of 2 1 B0. So it will be rewrite as 0 1 2 3. So for this consideration we take 4 values. So for 0, that is x0, x1. So here we want to function so x0, x1, x2. So this will be rewritten in terms of value of input function v0, v1. So we want x1, x2, x0 value. So it will be rewritten so in terms of function. So we generally 0 1 2 3 for the 3 variable written as 0 0, then 0 0 1, 2 for 0 1 1, for 3 1 1 it will be calculated. So for this function we take, then move to the function of here. So this is consider the term of, so where you want the function, so that term it will be calculated. So for b1 and b2, so combination of 0 0, so this is 2 variable system. So 0 0 1 1 0 1 0 1. So we want only b0 function. So b0 will be rewritten as, so those who are the combinated for b0, so here b0 calculated. So those who are calculated means first one 0, so 0, then 1, then 0, then 1. So it will be rewritten as x2 x1 bar into x0, then plus x2 x1 x0 value. So where it is will be taken where the output value is presented, that is the 1 is presented in between the value of b0 value. here 1 is presented here only. So this is x2 bar, this is x1 bar, this is x0. Then finally here, so x2 x1 x0. So we calculated these terms, so it will be rewritten as, so in this function both x0 is common, both the terms to taken out. So then x2 bar x1 bar plus x2 x1 into x0 value. So already I told, now only bar, both the terms are bar and both the terms are not complemented, it is XNOR gate. x2 bar x1 bar plus x2 x1, that is XNOR gate. x2 XR x1 the whole bar, it is called as XNOR. So whole function is b0 is equal to x0 x2 plus XR x1 the whole bar, or else x0 into x2 XNOR into x1. This is the final answer for given problem. That's all. Thank you for watching. If you like, share and subscribe my channel. Thank you.